All right, we are starting Unit 7A today. We're going to be talking about probability. And I apologize for the question mark in this little dash line. There's supposed to be a coin right here that has heads and tails options on it, and then a dice here. But it doesn't show up on my iPad. So we're going to get started. So we're talking about probability today. Oftentimes they write P and then in parentheses of whatever they're asking for. So if I asked you what's the probability of rolling a 4 on a dice, that's how they would write it. Okay? And we write probability as just a fraction, the part you want out of all possibilities. So the probability of getting a 4, well, there's 1 4 on a dice out of 6 total options. So the probability of rolling a 4 is 1/6 because there's 1/6, 1 out of a total of 6 options. Theoretical probability is what should happen. If you were to roll the dice 6 times, you should get a 4, 1 out of every 6 times. So theoretical probability is normally what we talk about when we just say the word probability. It means the same thing. But what actually happens is what we call experimental probability. If you roll a dice 6 times, you might get a 4 twice instead of only 1 time because it's based on chance. So when they say experimental probability, it's based on an actual experiment that you do or I do or that someone has done. So we're going to look at our probability. Normally we write it in terms of a fraction, but probability can also be converted to a decimal or a percent. The closer we get to 1 whole, the more likely something is to happen. So think of this as a scale from 0, never going to happen, like rolling a 0 on a dice. You can't. Rolling a 7 on a regular dice. You can't. It's never going to happen. To what we call certainty. Or 1 whole. All of the options. You know for sure that it's going to happen. Like, if you roll a dice, you'll get a number 1 through 6. Well, that's pretty certain that that's going to happen. Or if you flip a coin, you'll get heads or tails. That's certain that that is going to happen. Okay? So the probability they're asking us first of getting heads on a coin. Well, what do we want? We're looking for how many heads are there on a coin. There's 1 out of a total of all the possibilities. Well, there's 2 options. You could get heads or tails. And to get to the decimal, all we're going to do is divide, plug it in our calculator, and we get 0.5. And then our percent, to get to a percent, we multiply by 100. This is reviewing, getting from a fraction to a decimal to a percent, which is 50%. Hopefully you know that one. 50% of the time, you should get a heads. Second one, we have a cube. What's the probability of getting a 3 on a number cube? A number cube is just a dice. Okay? So we have a dice, which 6 numbers, 3 sides we can see, 3 we can't there. How many 3s are there on a dice? There's not 3 of them. The part we want, there's only 1 3 on the dice out of a total of 6 options. So we can plug that in our calculator, 1 divided by 6. And that would be repeating. Oops, I wrote that really big. There we go. 0.166 repeating. If we want, we can write that as 0.17 if we convert it or round it, sorry. And then multiply by 100 to get to our percent. It'd be 16.6% or 17% if we round it. So on the left side, we're going to look at our theoretical probability, what should happen, the part we want out of the total. And then we're going to do an experiment and see what actually happens. So what should happen, it says write the probability as a fraction and as a decimal. They're not asking for percent. So pink, somehow not all the P's showed up here. And these ones are clearly blue, but there should have been B's on there for blue. All right. So first, pink, we have 2 pinks out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubes. 2 out of 10, which we can simplify if we divide by 2. Goodness gracious, I'm going crazy here. Divide by 2. So we get 1/5. And if we plug that into our calculator, it is 0.2. Now they want to know how many green are there. There's 1, 2, 3, 4, 5 green out of a total of 10. We can simplify that and get 1/2, also known as 0.5 in our calculator. And then blue, we have 3 blues, 3 blue cubes out of a total of 10, which in our calculator that would be 0.3. So we wrote each as a fraction and as a decimal. So in an ideal or perfect world, this is how many times you should pull out a pink, a green, or a blue if they're all in a bag. But what actually happens? In class, I will have 10 people pull out a cube, and we're going to see what actually does happen. So we're going to start tallying. I'm going to just do this right here, and you can't actually see what I'm doing. But I'm going to pull one out, and it is green, so I'm going to put a tally there. Next one I'm going to pull is also green. Then blue. Then pink. Then green again. Green again, holy cow. Blue again. Green again. Oops, that was our 5th one. We should go diagonal. It's okay. Blue again. 2 more to get to a total of 10. Blue again. And then last one is green. So there weren't many pink ones pulled, but this is our experiment, what happened. So this was just one. Here we had 1, 2, 3, 4, 5, 6. And here we had 4. Oops, did I do too many? 1, 2, 3, 4, 5, 6. Yep, oh, that last one we shouldn't have counted. So our last one, I'm going to go back here. The last one was blue. So we had 5, I'm sorry, green. And then here we had 4. So what actually happened? Well, pink, we only got 1 out of 10 times that we did this experiment, which if I plug that in my calculator is 0.1. So it doesn't really correlate to what should happen. It's because we did an experiment, and that's okay. Oops, I don't know why I erased that. Green, we had 5 out of 10, which is what we were supposed to get. We were supposed to get 50% or 0.5, and half of them were green. It just worked out. And blue, we were supposed to get 3 out of 10 to be blue, but we got 4. So based on our experiment, we got more blue than we should have and less pink than we should have. But we wrote our probabilities based on the experiment. That's we call these experimental probability. And this is theoretical, what should happen in theory. On the back side, we have a spinner. It says write the probabilities, it just wants it as a fraction. What's the probability the pointer lands on an even number? So even numbers, divisible by 2. These ones are all even numbers. So we have 1, 2, 3, 4, 5, 6 even numbers out of a total of 8 spots on our spinner. Remember, probability is the part we want, or they're asking us, out of the total. Next, before I go on, I could divide by 2 to simplify that. 3/4 would be simplified. 3 out of every 4 times, we should get an even number, or 6 out of every 8, same. Probability, the pointer lands on a 4. Well, there's only one 4, so 1 out of, 8 was our total. 1 out of every 8 times, we should get a 4. What's the probability the pointer lands on a number divisible by 2? Also known as an even number. So we already did that one. 1, 2, 3, 4, 5, 6 out of 8, which we already simplified up above to 3/4. And then, what's the probability the pointer lands on a composite number? Composite means it's divisible by anything more than just itself and 1. Dividing by something more than 1. So something that's divisible by 2 or 3 or 4. The opposite of a composite, or the inverse of that, would be a prime number. Prime is only divisible by 1. Composite means it is divisible by multiple things. So a composite number, 2 is actually not composite because it's only divisible by 1 and 2. So same with 7. Can't include that. Can't include 7. That's a prime number. 5 is a prime number. It's only divisible by 1 and 5. The rest of these, 6, 4, 8, 12, and 10, are divisible by 1, the number, and 2 or 4 or something else. We have 1, 2, 3, 4, 5 composite numbers out of 8. Last slide here. Multiple choice is our first one. It says, what's the probability that you randomly choose a green ticket? So we're looking for green. Oops, that's the part we want. Green ticket. From a stack of 3 red, 3 green, and 5 blue tickets. So we need to find out the total. Remember, probability is the part we want out of the total. The total is 3 plus 2 plus 5. So 5, 6, 7, 8, 9, 10. And they want that we pull a green one. There's 2 green ones out of 10, but that's not an answer choice. So we do need to simplify. We can divide by 2, and we get an answer of 1/5, which is answer choice A. Next, same set of information. What's a probability of you getting a green or a blue? If they ask you for more than one, we're adding those parts together. Green and blue, we have 2 green and 5 blue. So that's really 7 out of 10 choices. So our probability is 7 out of 10. And then the probability of you, keyword here, not getting a green card. So how many are not green? Well, if 2 are green, the rest are not. So 5, 6, 7, 8 are not green out of a total of 10. We could simplify by dividing by 2 to get 4/5 are not green. All right, on your homework, show your work.